Right, good morning. Today we're doing Algebra 2, Lesson 710, the factor theorem. And so you're going to be able to use division to factor and solve polynomials. Before you get started with this, I would suggest, if you can, you go to Clever. I've added an icon in the Unit 7 section of Clever called the Solving Quadratics Homework Helper. It just says Solving Quadratics HH. That just is a nice cheat sheet that you could use to help you to remember some of the methods that you use when you get down to factoring at the quadratic and then the linear level. And that happens with all the polynomials. So this is something you can use with every single polynomial. Please go ahead and do that, okay? All right. And of course, you know that you're going to upload your notes to me as usual, and that's by 11:59 p.m. Saturday. All right. So let's take a look at this now. We're going to factor each of the problems that are going to follow and find all of the zeros. So let me just put in here, we're going to have, let's see, when we say all of the zeros, we mean real and imaginary zeros. Remember, imaginary has I in them. So imaginary zeros. So hint, in some of these problems, we're going to be finding imaginary numbers. And so then the other thing, of course, you want to remember is that you're going to be factoring all the zeros. That's the thing to concentrate on. All right, so we have this polynomial here, and we are going to factor, this is your factor here, x plus 1. And so what they're basically saying is that that is a factor to this. So whenever you get a question that they give you this and tell you it's x plus 1, you know that it's going to be a factor. All right, so looking at this, I've got a polynomial with, let's see, 1, 2, 3, 4 terms. And I could probably factor this by grouping, okay? But I also could use the synthetic division method. So we're going to have two methods here. We're going to do method 1, which is going to be the synthetic division method. And then we're going to do method 2 over here, which is going to be factored by grouping. All right, so let's think about how we're going to set this up. So if remember, if x plus 1 is a factor, then it has to equal 0. So what we would do is we would, of course, subtract 1 from both sides, and we would get x equals -1. So setting up our synthetic division, we've got -1 over here. And then the first thing here, remember we're dividing out an x, so x cubed becomes x squared. And since there's just one of them, then that means that it's 1x cubed, right? And then you have 1x squared, and then you have -9x's, and then you've got -9 as your constant. So we're going to go ahead and do our synthetic division. So when we do that, we're going to bring down first the 1, and -1 times 1 is -1. We're going to combine these two, we end up with 0. And 0 times -1 is also, let's see, 0. So we're going to put a 0 up here. And -9 and 0, combine those, you get -9. And then we're going to go to our remainder over here. And so the remainder, bring our -9 up. -9 times -1 times -9 is +9. And then combine the two, and you get a remainder of 0, which is what we want. This is good. So we have a remainder of 0. So our goal is to get a remainder of 0 if we can. So now we know that we have, to begin with, we have x plus 1 as a factor. So we would write x equals x plus 1. And then we can set up double bubbles. And the second bubble, we're going to take these terms here, and we're going to set them up and create a trinomial. So if you remember, we started out with x cubed. Now when we divide out an x, this becomes 1x squared. So we have 1x squared. And then we have negative 1x. Oh, this is squared. Okay, so this is negative. Oh, we got a 0 here. So this is a 0. So when we have a 0, we just ignore that. We go over to the next one. This is the constant, so that's negative 9. Okay. So setting this to 0 now, because we want these all to be set to 0 to find out what x is, we have 0 equals x plus 1 times x squared minus 9. And so looking at this, you notice that we've got difference of squares. And we could set all this to equal 0. So x plus 1 equals 0. And we can set this one, since it's set up as a square, we could do x squared minus 9 equals 0, right? And so subtract 1 from both sides over here on the left, and you get x equals negative 1. Let's do that again. X equals negative 1. So that's one solution. And then over here, if we were to add 9 to both sides, we get x squared equals 9. And then we take the square root of that. You get plus or minus 3. So x equals plus or minus 3, positive or negative 3. So there's your solutions for this problem. Okay, you've got 3 solutions: x minus 1, x equals 3, x equals negative 3. All right, so that's doing it using synthetic division. Now we can also do this using the grouping method because we have 4 terms. So we just write that 4 terms, so we can factor by grouping. All right, so our function is p of x equals x cubed plus x squared minus 9x minus 9. And so if you look at all of this, you can see that we could factor out, if we divide this into 2 groups, so we divide it up here, x cubed and x squared, we can divide out an x squared. And what can we divide out of negative 9x minus 9? Well, negative 9, right? So when we do that, we get p of x equals, all right, so we've got this x squared that we're going to divide out, right? And then what are we left with? When we divide out x squared, we're left with, this would be x squared, we're taking x squared out of x cubed, that would be x. Taking x squared out of x squared, we're left with 1. So x squared plus 1. And then over here on the other side, we have negative 9x divided by 9, so that becomes positive x. And negative 9 divided by negative 9 is plus 1. Right? So we have another x plus 1. So we can clean that up now. We now know that we've got, first of all, we have an x plus 1 here, right? So p of x equals x plus 1. And then I have x squared I've got, and I had a negative 9 over here. We forgot about putting that negative 9 in. So the negative 9 goes right here, right? Because the negative 9 was divided out of 9x minus 9, you get negative 9 times x plus 1. Just like when we divided out the x squared over here from x cubed plus x squared, we got x squared times x plus 1. So we have a negative 9. So x plus 1 is our first term, and then our second term is going to be the x squared and minus 9. Okay? So simplifying, we know that x plus 1, that factors into x equals negative 1. And over here, x squared minus 9, we know factors into, because we did it over here, you know, on the left, we know that factors into x equals plus or minus 3. So we're in the exact same position we were in here, right? And remember, this is now set to 0, so we'll set it to 0. And so the rest of it is the same. Okay? All right, so that shows you the two methods we could use. Either one works, whichever works better for you. Some people think factoring by grouping is better. Some people think the synthetic division is better. But sometimes you're going to have to use synthetic division because factoring by grouping doesn't always work. Okay, so let's look at another problem here. And here you'll notice that f minus 2 equals 0. So these are actually your solutions for what x is when y equals 0. Here's y equals 0 here. You know, remember the remainder theorem, y always equals 0. So this is your x, because f of x equals 0, right? So this is your x, now it's negative 2. So we've got solutions of negative 2 for x and y is 0. Okay? And because of that, we can say x equals negative 2, obviously. And so then we can go backwards and we can say, all right, x plus 2 equals 0. So here's our factor. That's our factor. Okay? All right, so knowing that, then we can set this up as a synthetic division problem. Now, why would I want to do that? Well, look at these. I can't divide anything common out of it, and I cannot easily factor this by grouping. It just doesn't look like it would work. So the go-to on this one would have to be to use synthetic division. Okay? So, my x is negative 2, because when I factored, you know, going backwards, x plus 2 is the factor. So negative 2 is what I'm going to use as a divisor over here. And then I've got 1x cubed, so I'll put a 1 here. Negative 5x squared, so I'll put a 5 here. Negative 2x here, so I'll put a negative 2. And I got a 24 over here. All right. And so the question is, what do we end up with for a remainder? If we end up with a remainder of 0, then x plus 2 has to be a factor of this. Okay? So let's just double check. So we'll bring down the 1. And negative 2 times 1 is negative 2. 5 minus 2. Oh, this is negative 5. I'm sorry. Let's double check these. That was positive 1, negative 5, negative 2, and 24. Okay. So negative 5 and negative 2 is negative 7. And then negative 7 times negative 2 is positive 14. And negative 2 and 14 is 12. And then negative 2 times 12 is negative 24. And so you see your remainder is going to be 0. Okay? So we can say then that x plus 2, which is what we had up here, is a factor of f of x. Which is, of course, what we call this. This is a factor of f of x. That's what we're saying here. Okay? So let's go ahead then and use this now to factor, continue our factorization. So f of x equals, we're going to use the x plus 2 for factor first. And then we're going to create a trinomial out of what we have here. So remember, we divided out an x, so we no longer have x cubed, we have an x squared. So this is 1x squared, right? And then negative 7x, and then plus 12. Okay? All right, and so we can set up x plus 2 to equal 0. So we know that that's going to be x equals negative 2. Now, looking at this, can I double bubble it? Well, let's see. What times what equals 12? That, when added together, equals negative 7. Well, I think, I know that 3 times 4 equals 12, right? But I want negative 7, so couldn't we do negative 3 and negative 4? And that would be negative 7. So seeing that, these are our factors. So we'll go ahead and rewrite this as, let's put this x plus 2 over here. And then double bubble. And I've got x minus 3 and x minus 4. Now that I've got that, then I know that this one, of course we said x plus 2 equals negative 2, x minus 3, x has to equal positive 3, right? X minus 4, x has got to equal 4. So these are our 3 solutions for x when y equals 0. Okay? Remember, y is equal to 0. All right. So let's move on. So now I've got a problem. Again, I've got my I've got 4 terms here: cubed, squared, x to the 1, x to the 0. So everything is in order. And here I've got, I want f of 3. So my solution, if you remember, has got to be x equals 3. Right? So if x equals 3, that's what I'm going to divide by. And if I set this up, you know, this would have been, again, x, let's see here. Now let's go ahead and do this. So remember, we could have set this up as x equals, x is not going to equal 0, right? So this would be actually x plus, or x minus 3 equals 0. And so x would equal 3, right? So anyway, 3 is the number that we want over here. And then we've got 2x cubed, so I'll put a 2 here. I've got negative 13x squared, so I'm going to put negative 13 here. I've got positive 26 and x's, and then I've got negative 15. Extend this a little bit more. All right, so bring down the 2. And 3 times 2 is 6. And then 6 and negative 13. Looks like that has to be, I'm left with negative 7 because the negatives win. And 3 times negative 7 is negative 21. 26 minus 21 is 5. 5 times 3 is 15. And you see again, we are lucky because our remainder is 0. Okay? So that means then that x minus 3, we saw that over here, x minus 3 is, right, times, and then, now remember, this had been cubed, but we divided off an x to get the factor over here, so this is now going to be 2x squared. This is now squared. This is going to be negative 7x, and then we bring down the 5. Right? Now, maybe I can go ahead and factor this, but let's just, for the kicks and giggles, as they say, let's go use the quadratic formula, because we've been talking about, possibly imaginary numbers. But if this is factorable, then obviously there is no imaginary number. But let's just do this. So I've got to remember what the quadratic formula is. So what is it? X is the opposite of b plus or minus square root of b squared. I can never do the music on this. Minus 4ac, all divided by 2a. Okay, so there's your formula. So in this case, we're going to fill in the information that we've got. So where is our A, B, and C? Remember, in this case, that 2 is going to be your A, 7 is going to be your B, 5 is going to be your C. And somehow or other, I forgot the plus sign there. Okay, so we've got, let's see here. Our B is negative 7, so the opposite of negative 7 is positive 7, plus or minus the square root of negative 7 squared minus 4 times our A is 2, and our C is 5, and that's all divided by 2, and our A is 2. Okay, so let's go ahead and simplify. So I've got 7, and then plus or minus. Now, all this stuff that's under here, we could do it with a calculator, and that's just a lot easier. So we're gonna do that. So I've got negative 7 squared. So let's turn this on, clear it, and I'm going to put in parentheses negative 7, and I'm going to square it, minus 4 times 2, close those parentheses. Oops, I did that wrong. I'm going to have to do it one more time. Let's do it one more time with feeling. Let's hope it works out. So parentheses, negative 7, in parentheses, squared. And then we're going to multiply that times 2. So let's use parentheses 2. I think it'll work this way. And parentheses, and then times 5. Whoop. Negative 4 times 2. Well, let's do the negative 4. So parentheses, negative 4, and then parentheses 5. Parentheses 5. And hit enter, and that is not right. So let's try that again. Let's clear this. So I've got negative, so parentheses, negative 7 squared. And then, oh, I know, parentheses negative 4. Okay. Let's try times 2 times 5. Close the parentheses there and see if that works. Okay. So that is not right either. Let's do it the easy way. So let's do negative 7 squared. So parentheses, negative 7 squared. And that's 49. So we're going to just do it this way. 49 minus, that's what it was. I put it negative, minus, and then this is 4 times 2 is 8, times 8 is 40. Much simpler. But you can use the calculator to help you as it works for you. Sometimes for me, I get kind of mixed up in my operations there with the parentheses and the operation signs. So that leaves me with 7 plus or minus the square root of 9, because 49 minus 40 is 9. Now, and this is all divided by 4. 2 times 2 is 4. So divided by 4. This is all divided by 4. Now, when we do something like this, you'll remember this is 7 divided by 4, plus or minus 3. So let's do it this way. 7 plus or minus 3, all divided by 4. And so I'm going to get two solutions. I'll get 7 plus 3 divided by 4, which equals 7 plus 3 is 10, divided by 4, which simplifies to 5/2. And that's a fine solution. And then I have 7 minus 3 divided by 4. 7 minus 3 is 4, divided by 4 equals 1. So now you see you've got 2 solutions here. And then also don't forget that you had an x minus 3. So x minus 3 equals 0. So add 3 to both sides, and you get x equals 3. And of course, they already told you that it was that up there. So that was already one of the solutions. This is one of the solutions. Okay, x equals 3. So we got 3, negative 5 over 2, and 1. Those are your solutions. Okay? All right. I'll let you look at the whole thing. Here's the, I don't know if I can squeeze it all in. And then I'll move it up. And you've got everything. Okay? All right. So let's move on. And so with this one, they tell you over here, x minus 1 is a factor. So if it is a factor, x minus 1 equals 0, so x has to equal 1, right? And the remainder is 0. That's what you want to remember. Okay, so we've got the 1, so let's just go over here and use it. So my 1 is the divisor, and I've got 2x cubed, so I've got a 2, I got a 2x squared, I got another 2, I got a 6x, so that's 6, and I got a negative 10. Right? Okay, so bring down the 2. 1 times 2 is 2. 2 plus 2 is 4. 1 times 4 is 4. 6 and 4 are 10. And 1 times 10 is 10. And, oh, looky there. Again, I've got a remainder of 0. All right. So I'm proving that this is a remainder, and so it's a factor as well. If 0 is the remainder, then the factor is x minus 1. Okay? So let's go ahead and, now that we've got this, let's use that x minus 1 over here as the first factor. And so you get f of x, let's do it down here, f of x equals, and in parentheses x minus 1, and then we've got, remember this is our 2 here, but this is now, it started out as x cubed, we divided out an x, so this is x squared. So we're going to have 2x squared plus 4x, because this is a 4, and this is a 10, so that's plus 10. So again, x minus 1, x equals 1 is the solution. It's already the solution. You already know what it is. Okay? Now, for the rest of this, so on this one, looks like you could divide out, but I'm going to just be cautious here because I want to make sure that I don't have any imaginary numbers. And like I said, there's some imaginary numbers in some of these. So let's use, again, the quadratic formula. So x equals opposite of b plus or minus b squared minus 4ac all divided by 2a. All right. So what do we got? Let's see. The opposite of b. Well, let's just let's color in her. So here's our a. Here's our b. Here's our c. So our a is 2. Our b is 4. So the opposite of 4 is negative 4. And then plus or minus the square root of 4 squared minus 4 times a, which is 2, times c, which is 10, all divided by 2 times a, which is 2. Okay. All right, so this equals negative 4 plus or minus, well, let's see, 4 squared is 16. Let's just do it this way. 2 times 4 is 8. Times 10 is, or 2 times negative 4 times 2 is negative 8. Times 10 is negative negative 80, right? And again, you can use the calculator on that, and that's all divided by 2 times 2 is 4. So that equals negative 4 plus or minus, now let's see, 16 minus 80, that's negative 64, all over 4. So here's the thing, I've got a negative in the radical. What do we have to do with that? You've got to remember, we have the square root of negative 1 equals I. So we're going to have to factor that out. So I'm going to have the square root of negative 1 and the square root of 64 multiplied together, right? And of course this is going to become I. So I'm going to rewrite as x equals negative 4 plus or minus, now the square root of 64 is 8. And again, you can use your calculator if you need to. And then you have your I, right? And that's all divided by 4. So your solutions are negative 4, we can just divide this, take this 4, make it the denominator to both of the two terms at the top. You can do that. So negative 4 divided by 4, then plus or minus 8i divided by 4. Now, what delta math will do is it will want to show this as two solutions in this fashion. So they'll probably say x equals 4 divided by negative 4 is negative 1, right? And then we've got 8 divided by 4 is 2, right? So plus or minus 2i, okay? Now that's perfectly good solution, but they might also want you to do it as x equals negative 1 plus 2i and x equals negative 1 minus 2i. So that may be, check it, I'm not sure which one in delta math will do, but it'll do one or the other, okay? All right, so this is an example of what happens when you have a negative number. So if I tried to factor this, this would not have factored for me using double bubble. That would not have worked. I would have had to done this, okay? All right, so we have one left to go. And so on this one, they're telling you, they say, here's your quadrinomial, or your polynomial, and let's see, cubed, squared, x to the 1, x to the 0. So it's all in order. And they want to know which of the following is a factor of f of x. All right, so if you have a factor of, for f of x, then your remainder, we've already seen this, your remainder has to equal 0. Has to equal 0. So if you look at all of these, what we can do is we could probably do a test here and determine whether or not your remainder is going to equal 0. So I'm going to do this. I'm going to just go and do a little test. I'm going to, over here, I'm going to test. So I'm going to start out here. Your solution for x minus 3 would be x equals 3. So I'm going to divide out a 3 from this polynomial. Okay? So this is 1x cubed. This is negative 1x squared. This is negative 17. And this is negative 15. So let's see what we get. So bring down the 1. So 3 times 1 is 3. Combine negative 1, negative, and negative 3, you get negative 2. 3 times negative 2 is negative 6. And I'm sorry, this is positive 2. Positive 2. Negative 1 and positive 3 is positive 2. So this is positive 6. So negative 17 and positive 6 is negative 11, right? And then negative 11 and 3 is negative 33. And quite obviously, if you look at this, you are not going to get 0. So the question was, would this be a 0? No. No. So this is not the solution because the remainder has to be 0. Okay? So that one doesn't work. Let's try the next one. So we're going to do another test. Let's move it down here. Put a little double line here. So in this case, we've got x minus 1, so x is going to equal 1. We're going to divide by 1 this time. So we're going to put our 1, negative 1, negative 17, and negative 15. All right, let's use red just for contrast. So bring down the 1. 1 times 1 is 1 times 1 is 1, right? So I've got a 1 over here, and 1 and negative 1 is 0, and 1 times 0 obviously is going to have to be 0, and 0 and negative 17 has got to be negative 17, and 1 times negative 17 is negative 17, and obviously again this is not a 0. No. Okay, because this does not equal negative 0. I'm sorry, it doesn't equal 0, it equals negative 32. This one up here, 33, 43, that was negative 48. So, no. All right, let's try x plus 2 then. So I'm going to put a little double line here. And let's take and do this one down here. Test. So what is my x going to be? It's going to be negative 2. So I'm going to do negative 2 and then divide out again 1, negative 1, negative 17, and negative 15. So bring it down. This is 1. Negative 2 times 1 is negative 2. And negative 2 and 1 is negative 3. Negative 3 times negative 2 is positive 6. 6 and negative 17 is negative 11. Negative 2 times negative 11 is positive 22. And you can see here, again, in this case, 15 and 22 and negative 15 is what? Negative 7. So this is not a 0. And the answer is no. So obviously it's got to be the last one. It's got to be x plus 1. But let's just make sure. So I want to use negative 1 as my divisor. And so then again I've got 1, I got negative 1, I got negative 17, and negative 15. All right. So bring down the 1, and negative 1 times 1 is negative 1. Negative 1 and negative 1 is negative 2. Negative 2 times negative 1 is positive 2. 17 minus 2 is negative 15. And then negative 1 times, whoops, negative 15. Negative 1 times negative 15 is positive 15. And so there you see it. Remainder, 0. Yes. Remainder. Okay. So, looking at this, again, you know, this one was a kind of a typical delta math problem. In fact, I set it up as a delta math problem. This was taken from delta math. So this is what you're commonly going to find. So, you know, this would have been your correct answer right here. right, to answer this particular question, if it were a delta math question. And, you know, you could graph this if you wanted to test yourself on it. And so if you were to graph it, x plus 1, that means your solution would be negative 1, right? So so here at negative 1, you would have a solution running through there. And if you took the rest of this and figured it out, you would have something like this: negative 3, negative 1, and 5, and your graph would go like this. Now you can test this easily using your graph. So if these were the solutions, right? X is negative 3, x is negative 1, x is negative 5. Then these coordinates are negative 3, 0. And then you've got the coordinates of negative 1, 0. And then you have 5, 0. Right? Those are x and y coordinates. So x is negative 3, x equals negative 1, x equals 5. Right? So just going backwards, like I did before, to find the factors, you get x plus 3, you would get x plus 1, or x minus 1, I'm sorry. Oh, this is negative 1. X equals negative 1. So this is x minus 1. But x is now plus 1, rather. And then this is 5, so this is x minus 5. Right? So, how do you test that? Get your calculator out. And we know that we could put this into our calculator. Now this one, let me just see if I can do this right without screwing up. So let's clear everything and let's go over to the y equals. And what I'm going to do is I'm going to put function in here. So I've got y equals, let's see here. So x cubed minus x squared minus 17x minus 15. And then I'm going to go ahead and graph that. So if you look at this graph, this sort of looks like this is going to be negative 3. You look at the tick marks, 1, 2, 3, negative 3. This looks like negative 1, and this looks like 1, 2, 3, 4, 5. So those match up with what I had here, and I knew this before. That's why I just filled this in. But if I'd had to at the beginning, I could have just set this up, and said, okay, I think, looking at this, I got negative 3 here, negative 1 here, and 5 here. And, you know, just to be absolutely sure about this, you can use the trace button. So you see this button here, which Casio also has. You could click trace, and it says x equals 0. Let's just make x equal negative 3. So, let's see, I think I can just put negative 3 here. And if x is negative 3, what does y got to equal? 0. It shows y equals 0. So that's correct for this, negative 3 and 0. Let's do x equals, let's do the trace again. Oops, let's see, I may have to go back. Trace, yeah, let's just redo this. Trace. It's going to have to make me good and clear out the graph to do this. But you could do this for the rest of these. Make x equal 1. Okay, x equal negative 1. Put x equals negative 1, you will get then a solution at -1 and 0, and then x equals 5, you'll get solution 5 and 0 when you trace on this. Okay, so that's basically it, and we are done. And thank you so much. I know this was a long one. We'll let you go. Hopefully this gave you a lot of information that will help you with Delta Math. Now I'm going to give you the Delta Math assignment. You used this before, but we're going to do it again. It's only part of the original assignment that I did for Delta Math for the previous, for I believe it was 7.8. Okay, talk to you later. Thanks. Bye-bye.